Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico class, lesson number 9. You'll also notice that this week's video looks a little bit different as I recently had knee surgery and there's multiple stairs between me and my studio, so I had to improvise a little bit. I'm on a different floor and don't quite have access to all the same tools I do in my studio. But that's okay, we'll still have a good video. In lesson number 9's homework, Paul talked to us about using the PWM output on the Pico to take an input value from the keyboard and then display that output on an LED. And to do that, I'm going to use the platform that came with my GeekPi kit. My Kepler kit is unfortunately not available to me at the moment, but this GeekPi kit I keep on a different floor, so I was able to grab it and use this, and I think it'll be a good tool to use anyway. I wanted to go over a couple of things on the GeekPi kit anyway that I've updated since my last video, so this is a good time to show that off. One of the things I really like about this platform is the integrated components. It has these nice little surface mount LEDs, it has these nice push buttons, and the buzzer on the end. And I really wanted to keep it all wired together so that when I'm writing my code, I don't have to sit and plug in just the components I'm using. I'd rather just plug it all in, keep it together. There's so much GPIO available on the Pi Pico that I thought it'd be just nice to leave it plugged in. And that's what I've been able to do. I've got jumper wires running from these center connectors for the breakout connectors for the onboard components, and then over here to the breakout for the Pi Pico. And as I was doing that, I was really struggling with these female jumpers. I'm not really a fan of the female jumpers because one of the things, in order to get them to kind of go downward, it puts a strain right on that connector, and I'm afraid of actually damaging the connector. And so you have to put kind of an unnatural bend in the wire. So my solution to that is to take it like this and put a knot in here. And basically what that does is it shifts the wire 180 degrees. Instead of wanting to go straight up, it now wants to go straight down. And that makes a nice, a very gentle type of path for the wire. And so again, I'll try to help you out here to see this. This might look like a wadded mess, but it's actually not. It's actually very nicely organized, one wire at a time, everything flowing down nicely. I've got the wires running underneath the ABS platform. So there's this screw-on ABS platform underneath the board to keep the connectors off of everything. And it's very nice and easy to just slide the wires right underneath here, kind of in the middle of the sandwich here between the board and the ABS. And then I come up here and I plug them in. I would have liked to do the knots here as well, but the jumpers in the kit weren't quite long enough, so I kind of had to improvise. And I think I got a gentle enough curve on this that I'm not really putting stress on these connectors, at least I hope not. But this is really nice because now I can work with this prototype type board and not have to rearrange jumpers to use the onboard components. It gives me a lot of options. As I showed in a previous video, you can do a lot with just software. You can wire up the hardware one way and then you can write all kinds of different programs. And you can imagine with having LEDs, push buttons, and a buzzer, there's a lot of different types of programs I could write using nothing but just this statically set up hardware. The other thing I wanted to show since I've done my video is the Pico that's in this board right now is not the one that came with the kit. It's actually a Pico W, more like what came in the Kepler kit. And while I do like getting the Picos with the pre-soldered headers, this is the one that came with the GeekPi kit and looks very similar to the one that came in the Kepler kit. It's got these male headers soldered to it. It's very nice to put into a breadboard or into like this platform that has the sockets where you can just plug it right into the board. But the downside is you have to use, if you're not using that, you have to use female jumpers. And I really don't like the female jumpers, and I just kind of showed why. They're sort of a pain to work with. What I really like is on the Arduino, how it has, instead of the male headers on top, like the Raspberry Pi has the male headers on top, and again, I have to use the female jumpers. The Arduino has all the female headers on top, so I can use the male jumpers. And so I thought, is there a way I can maybe add female headers to the Pi Pico W? And yes, there is. These are not what came with the Pi Pico. It came, of course, with just the standard male connector pins. This is called a stacking connector. And I really like these because it has a nice long male pin on one side, but it has the female socket on the other. They're called stacking connectors because you're supposed to be able to stack them. So if you're doing like multiple prototype boards, you can stack them on top of each other. That's the purpose of it. But I really like the fact that it's got the male on the bottom and the female on top, because what that means is I can take my Pico W and I've got the male headers on the bottom, so it pops into the socket, and then I can use all the breakouts on this Geek Pi board. But I also have the female headers on top, just like an Arduino, so I can use the male-to-male jumpers. And like I showed in another video, it's very easy to make those if you have wires and a good crimper or a good wire stripper. So this is really kind of best of the both worlds. It gives you the male for plugging into a breadboard or these sockets. It gives you the female so you can use male-to-male jumpers in your projects. So it was kind of an experiment. It turned out really well. So for those of you who need to get a Pico W and they come generally not with the headers soldered to them, before you solder them on, get these stacking headers and you can do the male and female. Definitely worth it. All right, enough about that. Let's talk about today's lesson. So I'm going to show you how I've got this wired up here. I've got four LEDs wired from GP16 to GP19. Sorry about that. GP16 to GP19 on the Pico. And I used resistor coloring as I did in another video where I've got brown is LED1 and yellow is LED4. But I didn't have a brown male-to-male jumper in this kit. The only brown jumper I had was the female to male. And so I was able to use the male header on the board because, again, this is sitting in the socket and I have the access to these breakout headers. So I was able to use the male header to do a female to male jumper to LED1. But then 2, 3, 4, I was able to use male to male using the female ports on the stacking connector. So I just wanted to point that out. And now let's take a look here. And the program is actually running on this board right now. It doesn't do anything because I haven't been touching the keyboard. But here we go. So instead of taking the voltage, as Paul was asking, I decided to do a percentage of brightness. So let's go ahead and let's turn an LED on here at 30% brightness. And so we can see LED 1 comes on partway. And so if we go to 50%, it gets brighter. If we go to 100%, and now we're at full brightness. Well, what if I put in an invalid value? What if I put in something like 230%? What happens then? Oh, look at that. We get two LEDs full bright, and the third LED is partial bright. So it's almost like it just kind of rolled over. It hit 100 on one, rolled over to the next one, hit 100, and then the remainder is on that third LED. Does the same happens if I do 340? Yep, same thing. So I've got three that are full bright and one that's about 40% brightness. And of course, if I go to 400, I can see that all four are lit 100%. Now, it's always important when we're taking user input to validate the input. So obviously values between 30 and 400 are valid. What if I go to 0? Does that turn everything off? Hey, look at that, turns everything off. What if I try to go negative? What if I try to go to negative 20? What happens then? Oh, it says it's invalid. Try again. All right, what if I try 500%? Something outside of bounds of 400%. Hey, look at that. We invalidated again. What happens if I use a decimal value? I'm going to do 56.324. And we can see it comes on part way, about probably 56% or so. So what happens if I use an alphanumeric like the letter J? Oh, that crashes our program. So one of the things we're going to learn going forward is better ways of validating user input, trying to think of what sort of things are the users going to put in that aren't valid to keep it from crashing the program. And there are some techniques we can use in the future, but those are outside of the scope of class, but I do look forward to talking about those in a future lesson. So now let's take a look at the code. So we're just importing pin and PWM, importing sleep, and any any programs I do on this Geek Pi board, I have this kind of default block. Move my mouse there. Sorry about that. I have this default block of where everything is wired, which GPIO pins are wired where, and then I go in and I actually turn off the onboard LEDs because sometimes I'm running a project on here and the LEDs will, when I fire up Thonny, it'll just stop wherever it's running and some of the LEDs will be lit. So I want to make sure those are turned off before I start anything new. So then I get down into my actual project code and my frequency that I'm setting my PWM at is going to be 1 kilohertz, 1000 hertz, and my maximum brightness is 65,500. And now I'm just setting up my four LEDs, GPIOs 16 through 19, and then I'm defining a PWM object for each one. And once the PWM objects are defined, I'm going through setting the frequency to my variable of frequency and then setting the duty cycle to 0, or basically turning the LED off before we do anything. So just all we're doing is initializing, identifying the pin numbers, setting up the PWM objects, and setting the duty cycle to 0 to keep them off. So now we get into the while true loop, and we're actually going to take user input. And we ask the user, what percent brightness would you like? And you'll notice that I'm taking this as a floating point value. That's so that I can accommodate when a user types a decimal, like you saw 56.24 or whatever I typed in, it'll take it in as a float, because if I don't do this, that will crash the program. So I'd rather take it as a float and then convert it. So it basically just does a round down, 56.28, whatever, it just round down to 56. So I'm forcing it as an integer there. Now, just like I did in my second iteration of lesson 6, I'm going to, instead of writing out the LEDs every time I check through there's a bunch of conditionals coming up. And rather than writing out the LEDs at every stage, I'm just going to set variables. And then once I'm through all of my conditional statements, then I'm going to write out the values once. That way I don't get the flicker that we saw in Paul's lesson 6 and 7. Because we're only going to write out the values. We're going to ask the user for input. We're going to calculate the values. We're going to write them out. And then we're going to stop and wait for the user to enter again. So we don't get any flicker there. So the first thing I'm doing is I'm setting my values. All four LEDs are set to 0, so they're off by default. And now I'm going to walk through and determine what value did the user put in. So our first test is greater than 300, less than or equal to 400. So basically, if the percentage is 301 to 400, we know that the first 3 LEDs will be lit 100%, and the fourth LED will be lit whatever the remainder is. So I come down here and I say my percentage minus 300. So that way I'm stripping off the first 300. I just want that remainder. So if my value is 320, we're going to come down here and say, okay, 320 minus 300, we're only going to deal with that 20%. Then I'm going to divide by 100 because I want to convert from a percent to a decimal. So now it's 0.2, and I'm going to take my maximum brightness times that decimal. So in this case, 65,500 times 0.2 is going to give us an output value of somewhere in the neighborhood of 1,200. I'm sorry, 12,000. Yeah, 12,000, that's right. Sorry, my head was not doing the mental math correctly. And then we set the value of LED 4 to whatever that percentage is, and then we just set 1 through 3 as maximum bright. Then we come down to, if it's between 201 and 300, we're going to do that same calculation on LED 3. LEDs 1 and 2 will be full. LED 4 will be off, but we don't have to set LED 4 as off, because if you look up here, I've already set these variables to 0. So I've cleared out the values. So it's assumed that LED 4 is already off, and this code isn't going to turn it on. And then we come down here, if our value is between 101 and 200, LEDs 3 and 4 will be off, LED 2 will have the remainder, and LED 1 will be full brightness. Between 1 and 100, we're just dealing with that first LED, the rest are turned off. And then if we're out of bounds, if we're greater than 400 and we're less than 0, we're going to say, nope, that's invalid, try again. And then again, after we get through all the conditionals, then I actually write out the LED values because I've calculated them out. Obviously they've changed. Sometimes they're zero, sometimes they're 100, sometimes they're some percent. I want to get all that done ahead of time and just write out the values once so that I don't get that flickering we saw. Now there is one important piece to this, which is the way this is written, and it is intentional. If I get an invalid entry, what's going to happen here? Well, what's going to happen is it's going to come up here, take the entry from the user. So let's say I put in 450, which is invalid. It's going to write all of my values to zero, come down here, say invalid entry, and then it's going to write out all zeros. It's going to turn off the LEDs. Another way I could have done this is to use another variable to store what the values were the last time they were entered. And then I could come here and say, I'm going to restore that value and write the same value again. That way the LEDs stay on in whatever value they were. So if it was 320%, I have 3 on, 1 at 20% brightness. It would just stay there instead of clearing it out to zero. I decided I wanted to clear it out to zero, but I did want to make the point there is actually a fairly straightforward way to just set up some extra variables to basically pass the previous values into the current value and then write it out so that it doesn't look like anything changed when you enter an invalid value. Um, so I hope that was informative. I hope this video turned out okay because it is kind of shooting from the hip a little bit. I do want to point out something, and I think the camera caught it okay. Maybe you noticed, maybe you didn't, but if you didn't notice, take a closer look. There's something fishy about the output values, and I think this is something Paul is going to talk about in a future lesson. Um, Maybe a little spoiler alert, we hit it on the Pi as well, but I suspect we're going to have to do some additional math in a future lesson. But if you know what I'm talking about, if you noticed, feel free to comment below. If you like this video, be sure to hit like and subscribe. Love the new subscribers to my channel. Thank you very much. And I will see you next time. For Simply Brian Enterprises, this is Brian. Have a nice day and thank you for watching.